horizontal asymptote at y equals 0. And then we could plot all of those points if we wanted to. I'm not going to plot all of them. We didn't plot all of them yesterday once we started graphing exponentials. So 0, 1, 3, 8 would be a good point to plot. And then we know the graph's going to get really, really close to the asymptote over here. And it's going to turn and go up to the right. So that's graph of an exponential. We looked at those the other day. That's what it looks like. We're going to use that idea to help us graph the logarithm. We're going to use that to help us graph the logarithm. For the table for the logarithm, what are the points in the table for the logarithm going to be? What's going to happen to these points right here? These points right here are going to switch. The x and y's are going to switch. So the points for the logarithm are going to be 0.125 is going to be the x value, and -3 is going to be the y value. So those are going to switch. So 0.125 is going to be the x value. -3 is going to be the y value. 0.25, -2. 0.5, -1. The next one would be 1, 0. Then we got 1, 2, and 3 would be 2, 4, and 8. So all of those x's and y's are going to switch. And this time, since we don't really know what these look like, I'm actually going to plot all of them in this case. 0.125 is really, really, really close to 0. So we're going to be really, really, really close to 0 right here at -3. 0.25 is not quite as close. 0.5 is about halfway in between. So we're really, really close to that y-axis there. Might be some asymptote or something going on right there. Then 1, 0, 2, 1, 4, 2, and 8, 3. So plotting those points, we might get a pretty good idea of what this graph of the logarithm is going to look like. As we get closer to 0, the points are just going to keep going down. Are we ever going to be able to go to the left of 0? The answer to that is no. So we are going to have a vertical asymptote. Logarithms will have a vertical asymptote. Try to plug in a number like -1 or -2 or -3. Guess what? It's not going to work. You're going to get a domain error in your calculator. It looks like an exponential, but kind of like turned sideways. So we're going to get really, really close to the asymptote, just like we did with exponentials. And then we're going to turn. Exponentials would have turned and went up. Logarithms are going to turn and go out to the right. So that's what our graph would look like. And if we remember anything about inverses that we learned at the beginning of the year in January, we talked about the graph of a function and the graph of its inverse. And we said, hey, those are always going to be symmetric about the line y equals x. So if we were to put this line y equals x on here, about right there, and we were to reflect that exponential graph that we did earlier, if we were to reflect that over this line, we're going to get this point right here, and it's going to look something like this. And we do see that that symmetry does still exist for exponentials and logarithms because they are inverses. So that symmetry does still show up there. So when we say it looks like an exponential kind of turned sideways, it's really an exponential reflected over the line y equals x. And that's what's happening. All right, let's talk about the domain and stuff. So far, every function that you've learned, the domain has been -infinity to infinity. You can plug whatever number you want to in for x. Your graph would always go to the left and always to the right. But that changes today. The domain is no longer -infinity to infinity. How far left can my graph go? It gets to a point, it can't go any further left, and that point is 0. It's not going to actually equal 0. It's going to get really, 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 really close to 0, but it's never actually going to equal 0. Just like with the range for exponentials, it gets really, really close to 0. What about the range for the logarithm here? How far down is our graph going to go? Well, that arrow is pointing down. This arrow looks like it's pointing to the right, but at the same time, it is going to continue to increase. It's going to increase very, very slowly, but it will always increase. So my range is negative infinity to infinity. With the end behavior, because the domain is no longer negative infinity to infinity, our end behavior is going to look a little bit different too. In the past, we would always write as x goes to negative infinity. And why would we put negative infinity there? Because this number right here was negative infinity. But that number is not negative infinity anymore. So this statement makes no sense for this graph, because this graph does not go to negative infinity. So we're actually not going to put negative infinity. If you wrote negative infinity there, I apologize. But we're not putting negative infinity there. How far left does our graph go? 0. It only goes to 0. So I can't talk about negative infinity way over here if my graph only goes to 0. So we are kind of using those domain numbers, like this number right here is this number right here. And for exponentials, guess what? It was negative infinity instead of 0. But what's happening to the y value? So as we go further to the left, and as we get closer and closer and closer to 0, what are the y values doing here? They're going down. And how far down are they going to go? They're going to go down to negative infinity. And if we were to explore a table and we were to type in numbers like 0.0001, we would get a really big negative number. Okay, like negative 1,000, negative 1,000,000. That number, as that number gets closer and closer and closer to 0, that number is going to get more and more and more negative, like negative 1,000, negative 100, negative 1,000,000. The closer we get to 0. Now the right side is not going to be any different, because the right side is still going to infinity. So as x goes to infinity, we can still write that for the right side. Is the graph going up, down, or leveling off? It is going up. And it's going to go up forever. Forever, it's going to go up. It's never going to go down. It's never going to level off. It's going to always go up. It's going up really slowly, but it will always go up. The asymptote in this case, if it was leveling off, we would have another asymptote there, and then we would put the number for whatever that asymptote is. Our asymptote is going to be x equals 0. X equals 0. Why x equals and not y equals? Well, you need to know the difference between a vertical line and a horizontal line. If we use y equals a number, that's going to be a horizontal line. We use those with exponential functions. The asymptote for exponential is horizontal, so our equation should be y equals a number. If we're doing logarithms, the asymptote is going to be vertical, and we're going to do x equals a number. What if you just write the number? What if we just write 0? Well, that's not a line, that's just a number. So we need x equals or y equals to represent that vertical line, or y equals to represent the horizontal line. X equals for the vertical line. And the asymptote for logarithms will always be the horizontal shift. If we were to shift this left and right, that asymptote is also going to move left and right. All right, cool. Let's look at 2 examples, I guess. The first one, f of x equals log base 2 of x plus 2. Log base 2 of x plus 2. The transformations, we need those more so that we can figure out what the asymptote is. This x plus 2 is inside the parentheses, and whatever is being added or subtracted inside the function is going to tell us how far left or right we go. And it's always going to be opposite of what we think. We see the plus 2, so we might think, oh man, that plus 2, we would normally go to the right, but it's going to be opposite of what we would think. So we're actually going to go to the left 2. And if we go to the left 2, what is the asymptote going to equal? The asymptote is going to equal negative 2. X equals negative 2. We can go ahead and put that on there. Go left 2. And we're going to put a vertical line at x equals negative 2. Now, can we get a pretty good idea what this graph's going to look like based on what we've learned so far today? Yes. It's going to start at the bottom. It's going to get really, really close to the asymptote, and it's going to turn to the right somewhere. Where? I don't know. Maybe if we find a point or two, maybe we can figure out where exactly it's going to turn and go to the right. So you can use your calculator, your TI-30, and you can hit the table button in TI-30. Or we can use the Desmos graphing calculator. We can build the table in there, just like we did with exponentials. We're going to delete the y1, and we're going to type this in. But in order to type this in, because we can't change the base on your calculator, we need to hit the fraction button first. And what's going to go on top? On top, we're going to have log of whatever's inside the parentheses. And in this case, we had x plus 2 inside the parentheses. And in the denominator, we had log of 2. So the denominator is going to be log of the base. And in your TI-30, you would type that in exactly like it looks, using the fraction. If you got the button where you can change the base, you can use it, but a lot of you do not. You can use Desmos on your test, but you have to use Desmos on the computer, not your phone. Mine's not working yet because I need to put on Desmos, I need to make this X. This X right here has to look exactly like this one. So it's missing the 1. And now I can plot some points like -7, -6, -5. And I can put all these points in there. And notice a bunch of them say undefined. Like, or error. Your calculator probably says error. And why does that happen? That happens because the number inside the parentheses has to be a positive number. And if I plug -7 in, -7 plus 2, that's a negative number. That's undefined. That is that domain idea, like, hey, if we plug a number in, it has to work. Well, if I plug numbers like -7, -6, -5, I plug those in, those don't work. So they're not part of the domain. The first whole number that is part of the domain would be -1 here. That's the first number that gives me a whole a point that's not undefined or have a map there. So that tells me that my asymptote is probably going to be at -2. So then we can graph -1, 0. So -1, 0, that's a point on there. And then we can pick another point, any point really. 2, 2 is on there. Scroll down. 6, 3 is on there. 6, 3, I didn't go that far, but we can put that on there too. 2, 2, and 6, 3, those are points on there. So what's the graph gonna do? It's gonna get really, really, really close to the asymptote right here. Really, really close. It's gonna turn and go out to the right. So there's our logarithmic function. The domain are the x values that we can plug into the equation and they work. The x values that do not give me a domain error. The x values that do not say undefined. And what x values can we plug in this time? Looking at the graph, we can see that as well. It's going to be all of the points on the graph. So we can plug in numbers really, 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 really close to -2, like -1.9, -1.999999999. But we cannot plug in -2. And that's why we use a parentheses. That represents, hey, we can use any number all the way up to -2, but not -2. If we could use -2, then we would use a bracket. And that would say, hey, we can use all the numbers up to -2, including -2. The range for any logarithm is always going to be -infinity to infinity. One side of the graph is going to go down. In this case, the left side for us, and one side is going to go up. Always, for logarithms. One side will always go up, one side will always go down. What are we going to use for the behavior? Can't use -infinity anymore. We're going to use the asymptote, which is -2. That's going to be the left side, and then the right side, we can use positive infinity. So as we go further and further to the left, and we get closer and closer to -2, what are the y values doing? They're going down. And they're going to continue to go down forever to -infinity. And as we go further and further to the right, what are the y values going to do? As we go further and further to the right, they're going to continue to increase to positive infinity. They're going to continue to increase to positive infinity. For the x and y intercept, if you can look at the graph and say, hey, the x intercept is -1, and that is the case here, just write -1 down and move on. However, that's not going to always be the case, and we knew that wasn't the case yesterday. So how can we find the x-intercept here if it weren't sitting at that whole number point? Maybe it was sitting like somewhere between some points or something. We would set our equation equal to 0. We would set our equation equal to 0, and we would have to solve for x at that point. So just to show you what that looks like, it's not necessarily, we don't necessarily have to do it for this problem, but just to show you, we get log base 2, x plus 2 equals 0. It's been a minute since we solved log equations. In order to solve log equations, you need to get the log by itself. And at this point, the log is already by itself. If we were like adding something, we would have to move that to the other side, and then the log would be by itself.
I thought you put 0 plus 2, not it equal to 0.
That's for the y-intercept.
Oh.
If we want to find the x-intercept, we said y equal to 0, and now we can rewrite this as an exponential. 2 is going to be the base. 0, what the logarithm is equal to is always the exponent, and the exponential is always equal to what's inside of the parentheses. So 2 to the 0 is equal to x plus 2. And then we can subtract 2 from both sides to get x by itself. And we can type this left side, 2 to the 0 minus 2 in our calculator, exactly like it looks. And we're going to get -1 is equal to x. So for the x-intercept, we're going to set the equation equal to 0 and solve for x, whether it's an exponential, a logarithm, a square root, a cube root, absolute value, quadratic, linear, it doesn't matter. If we want to find the x-intercept, we set the equation equal to 0 and solve for x. To find the y-intercept, the y-axis, every single point on the y-axis, the x value is equal to 0. So we get log base 0 or 2. Log base 2 of 0 plus 2. If you've already created a table for this, all you have to do is find 0 on the table, and there's your y-intercept right there. It's going to be +1. If you need to type this in the calculator, though, maybe you did this without graphing it. Maybe you didn't graph this first, and you just want to find the y-intercept without graphing it. For the TI-30, we're going to have to type it in this way. Log 0 plus 2 on top and log 2 on bottom, because we can't change the base in the TI-30. And we get 1 when you type that in the calculator. So we do cross the y-axis at y equals 1. Okay, cool.
We're done?
Almost. Last example, the only reason I want to show this to you is because of the 1/2. If we change the base, just like when we change the base for exponentials, it changes the direction of the graph. Well, when we change the base for logarithm, it's also going to change the direction of the graph. So my transformations here, this one's going to go right 1, and the +2 is going to make it go up 2. And since we went to the right 1, our asymptote is going to be at x equals 1. Our asymptote is going to be at x equals 1. That 1 is going to have huge implications on the domain and the end behavior.
Why would
Because our graph went to the right 1. The 2 tells me how far up or down it goes. And if I move a vertical line up or down, it's still in the same place. But if I move that vertical line left or right, that vertical line is going to change. So for exponentials, this is going to be the horizontal asymptote for exponentials. But for logarithms, this is going to tell me what the asymptote is for logarithms.
Oh, so we always do like the opposite sign of what?
Yes, that's correct. So we get x equals 1. What's that graph going to look like? Well, we can make another table, pick a couple points. But because it's 1/2 now, just a rough sketch, this graph's going to look like this now. It's going to go down instead of up. So let's make that a little bit more accurate. And let's pick some points in our table. So in the TI-30, you're going to have to type it in this way. You're going to have to put log 1/2 on bottom. We're going to put the log x minus 1 on top. And then outside of that fraction, we're gonna put the +2. So anytime we add or subtract something to that, and we're trying to type this in as a fraction here, you wanna put the +2, outside the fraction. What if I put the +2 in top? Not the same. What if I put the +2 in the bottom? Not the same. What if I put +2 on the top and the bottom? Not the same. So put the +2 outside by itself. If you are using Desmos though, if you're using the TI-30, you need to type it in this way. If you're using the Desmos graphing calculator, there's actually a button on here that will allow you to change the base. So it's under the functions button, and it's this log with the little a next to it. And we can actually change the base to 1/2 now. So we actually do not have to use the fraction button on Desmos. And we can type this in exactly like it looks, make sure we put x1, and it's gonna give me the same points. So Desmos will allow us to put the 1/2 there. Notice we get a bunch of undefined points. That just means like the graph's not gonna go that far left. It's probably gonna stop going left at x = 1. Like x = 1 is gonna be where it kind of stops. So that's gonna be our asymptote. We see some points here, 2, 3, 4, 5, 6, 7, 8, 9 looks like a pretty good point. So 9, -1, and maybe 2, 2. So 2, 2, and 9, -1 might be some good points to use. 2, 2, and 9, -1. And now we can see that this graph's gonna be decreasing instead of increasing. So we're gonna get really, really close to the asymptote at the top, and we're gonna turn and go out to the right, something like that. Domain, we're gonna get really, really close to 1 to infinity. The range would be -infinity to infinity. The end behavior. The end behavior. Since we are not going to -infinity, we have to use something else, and we're gonna use the asymptote. So as x gets closer and closer and closer to 1, what are the y values doing this time? The y values are actually going up. So this would be positive infinity. And the right side of the graph is actually going down. So the right side this time would be negative infinity. How do we find the x and y intercepts? The same way. Looking at my graph, it looks like it's close to 5. I didn't plot that point. Maybe it was exactly 5. I'm not really sure. I didn't plot that point, so it's hard for me to tell that it's exactly 5. So I would need to set the equation equal to 0 and solve for x. So log base 1/2 x - 1 + 2 = 0. How might we solve that equation? We have to subtract the 2 first. Have to subtract the 2 first to get the log by itself. So log base 1/2 x - 1 = -2. And now that the log is by itself, we can rewrite this as an exponential. I've had people ask me today, can I just type that in the calculator like it looks? No, you're gonna type the x in there and it's not gonna solve for x. So we have to rewrite this as a logarithm. From a logarithm to an exponential, the base is gonna be 1/2, the exponent is gonna be -2. That's gonna equal what's inside the parentheses. And we have to get x by itself before we can type anything in the calculator. So we have to get x by itself before we can type it in the calculator. And then we can add 1 to both sides. And now we can type this 1/2 to the -2nd power plus 1 in the calculator. And we do get 5. So you will get 5 exactly. So maybe I could have plotted that point. But it should be 5 exactly. For the y-intercept, just to show you, we're gonna plug in 0 for x. 0 - 1 + 2. Can you type that in the calculator exactly like it looks? Yes, there's no variables in there, right? So you can type that in the calculator, the whole thing. You may have to use the fraction button, right? If we're using the TI-30, log 0 - 1, and on the bottom, log 1/2, and then +2 on the outside. But maybe you look at that and you're like, man, I'm gonna get a domain error. And why are you gonna get a domain error? Because the number inside the parentheses has to be positive, and 0 - 1 is a negative number. So you will and you should get a domain error this time, And what does that mean if you get a domain error when you're trying to find the x-intercept or the y-intercept and you did everything correctly? It means there's not one. So in this case, there would be no y-intercept. And if you had looked at the graph, if we had looked at the graph, we could see like, hey, my graph's not gonna cross, the y-axis here, because it doesn't go that far left. It stops at 1 and only goes, really close to 1, but it does not go to the left.